Hey everybody, welcome to CodeChat. My name is Jeremy Foster, aka Code Foster, and you can find me online at codefoster.com. And joining me today is Andrei Kashcha. How are you, Andrei?
Awesome, thank you. How are you?
Good. Thanks for joining me on CodeChat today.
Yeah, thank you for inviting me. Very excited.
I'm looking forward to our conversation. Andrei was at an event here in the Pacific Northwest in the United States called Cascadia.js. It's a popular conference for people that are involved in web technologies, JavaScript, Node.js, and things like that. And he had a really cool visualization package that he's created, and I invited him on to CodeChat to talk about that. So why don't you tell us what you've made?
Totally. So this is a visualization of graphs, really, really large graphs with hundreds of thousands of nodes and maybe hundreds of thousands of edges. And this visualization is a JavaScript library which runs in the browsers. It also works on the mobile phones using browsers as well. And at Cascadia.js, I presented this website which combines visualizations of different package managers, like software package managers. Okay. For example, NPM or NuGets if you're coming from .NET background. They're all visualized here. And at Cascadia.js, I was just showing how to build visualizations like this and what are the main obstacles here. So yes, this is basically the website, and you can explore all these different graphs in an interactive 3D mode.
I think there's a couple more showing here than what you even showed a few weeks ago. So you've been doing some work on this, huh?
Yeah, after I showed it at Cascadia.js, actually, I got so many requests from other people to visualize their own package managers, like visualization of Debian package manager, which is a very large Unix package manager or Linux package manager. So it's keep growing, and I'm actually happy to visualize more graphs if you have them. So I'm super fascinated by this.
Okay, and now what's the largest graph that you've been able to visualize? Like, how big does this get when you say it's really big?
So currently, the main limitation is browser memory. For example, in Chrome, there is an upper limit for the RAM which you could use, which is like 1.5 gigabytes of RAM. At least when I tested it. In Firefox, it could get larger. So in Firefox, I was able to visualize a graph with almost 4 million nodes and 35 million edges.
Okay.
And it also requires lots of GPU memory because this is all WebGL based, so you need to have a powerful GPU card. In this visualization and on the mobile phones like Androids or iPhones, you could render graphs with maybe 200,000 nodes fairly easily with 60 FPS frames per second. So
Okay, I know a lot of the package managers are creeping up on that 200,000 mark, so we might be pushing the limit in mobile there.
Yeah. So here's an example of one of the largest package managers here. This is a Go search which you can explore. So every white dot here is a Go package, and I'm not rendering all connections between the packages. That's on purpose because otherwise it's going to be like a huge hairball here. So it's going to hide the structure. But you can see that the position of the package is defined by the force-based layout algorithm. So all these white dots here, they're pushed away from the main cluster because nobody holds them there.
Okay.
And they pushed away from the main cluster by just using this physical simulation. So I pretend that every particle is every node is a charged particle, right?
Okay.
And then I have a bunch of physical forces acting on those nodes. Every connection between the nodes, it represents a spring, so the spring holds two particles. Then you run this physical simulation for many iterations, and then you have forces, and then from the forces you can figure out the position of the node by solving equations.
Okay, so you've got one force that's trying to get it out and away from everybody.
That's right.
And then you've got another force that's pulling it into the center.
Yes, it pulls into the center, pulls together the connected packages or the nodes which are connected by an edge.
And what's to keep the nodes that are disconnected from spinning off into space?
Nothing, actually. So if you keep running this for too long, it's going to fly far away. You never see them.
I see. So you have to kind of set a certain amount of time because otherwise they're out of there.
That's right. So yeah, and this is all running in the browser, and FPS is pretty high here.
Wow, that's so impressive. It's so great to be able to like spin around and see something that you've until this point only ever experienced from the command line or maybe from a web page.
There are lots of surprises in these graphs. Like once I visualized the Bower, which is another JavaScript package manager. It's not very big, but it's fairly popular. I saw lots of surprises in bar. So this is bar. It has maybe 30,000 packages, not very large. But in bar, you can see immediately there is two main clusters. The size of the dot here, like here and there, represents how many packages depend on this package. So this is a package in the bar community, and this is the package in the bar community, and somebody depends on them. So the more packages you have depend on that, the bigger your size is going to be. So
now I'm totally curious about what those are.
Exactly. So you can see like what's so surprising about bar? Why there are two main packages? But we can explore them here and see what are they. So we can fly here. Hover over, and this is jQuery. So
there it is.
jQuery has almost 4,000, more than 4,000 packages. This graph is probably 1 month old, so it's probably grown up. And the other package is actually Angular. So you can see that the Bower packages are split by Angular and jQuery. And there are also lots of packages which do not depend on anything. So you can fly to this outside of the galaxy and see the star field here, so these packages, they do not depend on anything, so you can click on them and see like this has 0 dependencies and nobody depends on that.
I love that it has such a physical analogy. We instantly visually relate with this because we're used to thinking about the stars in space. Can you tell me what I'm thinking that the mushrooms around those big players are probably the dependencies on those?
Exactly.
Is that right?
That's another discovery from this visualization. These mushrooms, they have just one single dependency, which doesn't let fly these packages far, far away. So if you hover over any of this, you will see that they have just one dependency, like here.
Okay, so that's why they're relatively close in proximity to that one large star.
Exactly, and that large star is in the middle, in the main cluster, and it stays there because it's very heavy.
And then this other mushroom that I see, is that one the packages that have dependencies on both jQuery and Angular?
You see this mushroom?
Yeah.
So this is super fascinating about the bar, and this is not really Angular or jQuery. If you click on any of them, you will see that actually they have 0 dependencies. So they do not use anything. They do not use jQuery. They do not use Angular. But contrary, somebody else depends on them. So there is a package in the Bower, the package manager, which depends on all these clusters. And if you click on this one dependent, it will it should show. Maybe I broke something. Let's see. No, my site is broken, I believe. All right, I know this is the package.
There it is, yeah.
Yes, this is the package in the middle.
Everything. So there's a package called Everything that tries to depend on everything.
Yeah. This package, I guess it was just fun experiment by somebody who wanted to include dependency on every possible Bower package.
And based on his experiment, he's changed the shape of your graph.
Exactly.
That's interesting.
So the package was created 1 year ago, and you see how the Bower changed since then. So 1 year ago, Bower probably has 15,000 packages, and now it has more than 30,000 packages.
Now, Andrei, what about these little clusters that I see with the lines? I mean, a lot of these don't have any lines, so you said that you're not drawing all of the edges because it would make this too convoluted, but I do see some constellations that have lines in them.
Yeah, so this is just, you know how in real life sometimes you don't want to show everything to not overwhelm the users, right? The same approach I'm taking here. I don't want to show the real graph with all the connections to not obscure the picture. So I want to just show edges which are relatively close to each other. This closeness currently is defined by just geometrical distance between two particles. So it's just, if your edge is smaller than like 100 pixels or maybe 200 pixels, then I will draw the edge. Otherwise, I will not.
Okay.
But it also shows that you can see the kind of little communities within the Bower package manager. So these things.
These are modules that work well together?
Yeah, they probably depend on each other.
Yeah.
Like in this example, you see they all have something per script.
I see.
So it's like maybe a namespace.
Somebody's maybe created a family of modules.
Exactly.
Okay.
If you look at NuGet package manager, you will see different clusters of the TypeScript or different clusters of
like entity framework.
Yes, exactly.
Okay,
exactly.
Gotcha. Okay, well that's really cool.
Yeah.
Now, can we look at the NPM
Yeah.
store? That's one that I spend a lot of time in and have more of an affinity for. And when I'm looking at the thumbnails that you have, I'm curious. I'm kind of expecting package managers to end up looking the same in aggregate, like in the macro view. You know what I mean? And yet they don't. Maybe we could jump back to the thumbnails. Actually, it's interesting to me that these package management systems look so distinct. Do you have any take-homes from that? Like, what have you learned from the overall view?
They are distinct, but there are still parts which are similar. Those mushrooms, for example, they usually are in every visualization here, so they're common to everything. But partially it also is due to the way they manage dependencies. For example, Go, it has lots of little constellations. It's just because the Go language, they don't have a package, but they import the packages based on the GitHub URLs, for example. So they have lots of files which depend on each other, and that's why the Go graph is very large and very sparse.
Okay.
Yeah.
Okay, yeah, so let's look at it. Maybe can we look up my module? Do you have a facility to search?
Yes.
Okay, it's called Candyman.
Candy?
Oh, and it takes us right to it. How cool is that?
Yeah.
Okay, 2 dependencies, no dependence. Boy, that's sad. No dependence. Somebody go use Candyman.
Yeah. Yeah.
There it is. So I'm just like this little star out in the middle of this huge constellation.
Exactly. I'm not sure what's happening here. Oh, look, this is working now. In the Bower visualization, it wasn't showing the things here. So I probably should go back and fix this. But for the Candyman, you can immediately see that you depend on Q, which is a promises library, and SSH too. Interesting.
Yeah, Candyman is a module for. So I've got it right here. I've got a little Intel Edison. I do quite a bit with IoT, and sometimes I'm working with multiple of these devices, and they're basically just a bunch of little Linux machines, and what I want to do is push my code after I've written it, push my code out to the device, like deploy it, you know? And there's various ways. I mean, I could even use NPM to publish and then install from NPM, but I don't, or use GitHub to push and pull, but I don't like those models. I like to be able to just send it directly, and so I made Candyman, which is basically just the ability to run either local or remote shell statements with promises, so that I can chain them together, and I can do, I can say, I want to SCP these files up, and then I want to do this, and then I want to do that. And so that's why I'm depending on SSH too, because I'm SSHing to run remote commands on the Linux boxes.
That's very nice. So good.
Okay, so the amazing product that you've created here, what are your plans for it? Why did you create it? What's down the road? What are you going to do with it?
That's a great question. Personally, for me, this is just a hobby.
Okay.
I'm not making money of this. I truly enjoy seeing the graphs. Like, it's something which is hidden and very complex, very beautiful, and they love this. I just love to see this. So it's part of this artistic thing, but the other part of it is I also have a goal to visualize the entire internet. I know this is crazy, like, but every page, if you think about it, it's connected by an edge. Like every link is an edge, right?
Link,
So I want to see how the internet looks like. This is very, very like challenging thing to me. So I like this. It's we have probably several billion pages on the web. So how do we render the graph, which is several billion pages, and what we will see if we render that graph? So I just want to explore that opportunities, and also these visualizations, they help you discover things which were not visible before. I have visualization of the GitHub, for example, which shows who follows whom, and in this visualization you can find clusters. I can show you.
Okay, so it's not related packages like the package managers, it's
That's
people.
right.
It's more about relationships between people.
So this is one of the largest graph here. It's gonna take like 20 megabytes of data to download.
Now I'm going to try to access this on my phone. I believe you've got a short URL for us, right?
This is the short URL.
Okay, so anybody can go to this?
Yes. What phone do you have?
I have a Windows phone.
Oh, let's see.
And you know what? I've already done this and it works great.
Okay.
Otherwise I'd just be embarrassing myself, wouldn't I?
At the conference, it didn't work because I didn't have IE to test with me, but after that, I fixed one bug, so I hope that fixed the Windows one as well.
Okay, so I've got, I don't know if we can see this on the screen here, but I've got the list of packages in a vertical list here. And, oh wow, look at it, it's moving even, it's animated even
Nice.
in this little list here. So I'm going to go to the NPM package. Oh my goodness. Oh, and that's right, you've got it hooked up to the accelerometer. So like right now I'm looking out in space and then I move my phone around. So this isn't going to work well for like showing the camera, because in order to see the center of the nucleus of the cloud, do you have a better name for that? The nucleus of the cloud?
No, that's fine.
Okay, the nucleus. Well, where is it? Okay, here we go. Now there's no way for the camera to see this, but we've got the nucleus of the cloud here, and then what, I single tap to zoom in?
Mm-hmm.
Oh, this is amazing. So on my phone, I can WebGL right into this whole cloud of dots. That's so neat.
It's amazing how powerful the technology is. Yeah.
Yeah. Now, you mentioned that this is a JavaScript library. Is it using any popular JavaScript libraries like Raphael or D3 or anything that we know of, or is it kind of written from scratch?
So the entire thing consists of hundreds, almost hundreds of little modules. So I'm using 3GS to render the scene, but the rest is built from scratch. So yeah, 3GS is used as a rendering engine.
Okay.
By the way, here's the GitHub, right? Okay. I mentioned to you that you couldn't see this before, but in this visualization, you immediately see the cluster of people who follow each other. It's just fun to explore. Why do they do this? Or see something which was hidden before. And
yeah, this feels more meaningful because it's people as opposed to just project dependencies.
Yeah, and if you think about the internet currently, we mostly think about it as a search box. Maybe it's Bing, maybe it's Google. But if you think about internet, it's a search box. But maybe it's not a search box. What if you could explore the internet this way? What would you see? Maybe you would see like different constellation. This is Reddit, this is Microsoft, or something like this. So I want to really
absolutely. And maybe you could do the equivalent of, remember in the Yahoo days when you would go to Yahoo to browse an index, a supposed index of the web, versus going to Google to do a search of the web.
Yeah.
And I wonder if something like that would allow me to do a little bit of a stroll through the internet. You know, like browse through and like, oh, who did I happen upon and who did they know? And
yeah, that would be interesting.
Yeah, that would be interesting. I think there's a lot of data that is meaningless to me as a human until I can see it with my eyeballs.
Exactly.
You know what I mean? Because you could, I don't have the time for somebody to describe it to me cerebrally, you know, try to understand it in my mind, but if it's shown to me, then all of a sudden it's completely clear.
That's true. Yeah.
Okay, so this attempt to visualize the whole internet, are you well underway?
Yeah, it's probably like a year ahead, but we'll see. I'm a developer, so probably need to multiply by 2 or...
Yeah, we do tend to overestimate.
Okay. Yeah.
Excellent. Well, anything else you want to tell developers before we go?
Graphs are super fun. If you like challenge and if you like to learn something new, explore graphs. Not necessarily visualize graphs. But maybe run some algorithms on graph, like find page rank of the graph or something like that. There are lots of interesting ideas you could mix up together and come up with something else. This is how Google started. They just had the graph of the internet, right? And then they came up with a clever algorithm to rank each node in the graph using the page rank. And now you know where Google is, right? So maybe you could create a new Google. So graphs are fun. Go explore them.
What's a good way to get started with graphs?
I think it's going to maybe Amazon and trying to find the book on the graph.
Okay.
Amazon is fairly good at finding really good books too. So for me, it was just creating a library which visualizes graph, and they learned a lot from that. So
wonderful. Yeah. Well, thanks a lot for this chat, Andrei. I think it's been really fun. I hope you guys enjoyed it too. Thanks a lot for joining us on CodeChat.
Thank you.